time. I made a little mark here. Okay, for this one, the whole trick here is we have to do some algebra. This technique requires algebra. For instance, if you see x to the fifth plus x to the fourth minus x minus 1, you learn to regroup. You learned to group this and factor out a common factor. So this would be x to the fourth times x plus 1 minus, and that's a factor in a negative one, and it's an x plus 1. And that would end up being x plus 1 times x to the fourth minus 1. But we can factor that, x to the fourth minus 1. So we have x plus 1 times x squared minus 1 times, and we lose our pen. Go away. I don't want that. X squared plus 1. That you can't factor, but that you can. Keep factoring. Get x plus 1 times x plus 1 times x minus 1 times x squared plus 1, right? Which means it ends up being x plus 1 squared times x minus 1 times x squared plus 1. You need to be able to do that because you're about to have to do that. You know why? Because here in a minute, that polynomial is going to be in my denominator. And I have to factor it in order to bust it up and be able to integrate it. Because this is going to be my denominator, and this is going to be a repeating linear factor. It would be lovely if I didn't have to repeat myself, so maybe you should stop talking. This is just a linear factor. Do we all agree it's linear?
Yeah.
And that is an irreducible quadratic. X squared minus 1 is quadratic, but it's reducible, right? You can actually factor it. When you get to something you can't factor anymore, it's called irreducible. In order to use the algebraic technique we're going to use to bust up a rational function, do you remember what a rational function is?
Yes.
It is the ratio of two polynomials. I'm going to give you the ratio of two polynomials. You're going to factor them both completely. You're going to remove anything you can remove, because you just removed a whole. And then what you're left with, in the bottom, you want to have linear factors, repeating linear factors, and irreducible quadratics. It can get worse than that, but we're going to stop at irreducible quadratics. Once you get it to that, then we're going to break it up into fractions. So, rational functions means you have a numerator that's a function over a denominator that's a function. And in our case, we're going to have some numerator to be named later over that polynomial, x to the fifth plus x to the fourth minus x minus 1. And you learned all that algebra at one time or another. You learned to group. You learned to factor. You're going to have to use it. So some of y'all need a lot of practice. A whole lot of practice. So this is going to be some numerator is equal to a repeating linear factor times a linear factor times an irreducible quadratic factor. And the technique I'm going to show you right now, which is partial fractions, is I'm going to show you how to take that and turn that into some coefficient over x minus 1 plus some coefficient over x plus 1 plus a different coefficient over x plus 1 squared. So when you're having a repeating linear, you have to have a fraction with the first factor and then a coefficient over the factor squared. And then plus, to handle the irreducible quadratic, you have a linear function, which is dx plus e over my irreducible quadratic. Once you bust it up into that, if a, b, c, d, and e are just numbers, can you integrate those? Yep, you can.
Wait.
There's no waiting.
Wait, why is there an extra x plus 1?
You didn't listen to me just now, did you?
Nope.
Because it's a repeating factor, because this is repeating linear, we have to have it once, then we have to have it squared to account for this, to get it all accounted for, and to be able to integrate it completely. We have to have all the just plain linear factors have a coefficient divided by the linear factor. Then if it's a repeating linear, I have to have it to the 1 power and then the 2 power. If it had been cubed, I would need it over x plus 1 over x plus 1 squared and over x plus 1 cubed. I have to keep taking account of it. That's how you handle repeating. And then if it's quadratic, I need a linear function on top. So I have, it's mx plus b. And I have to find those coefficients. That's kind of like mean and nasty. This is easy. Linear is easy. Quadratics suck. Well, they don't, but it's like, yeah, we'll be at this for a while. Okay, so what happens is, to compare these, I would have to get a common denominator, right? Do we all agree? So if I get a common denominator, what is missing on the A? So I'm going to rewrite this. So what is this missing? It is missing, hang on a second. It is missing, it's just one of those days. It is missing, that's just not writing there. Why is it not, oh, this is really weird. The pen, she doesn't like me today. No, it's not responding right. Huh, that time sort of responded. It's as bad as my erasers. Okay, anyway, continuing. So if I need a common denominator, it would be lovely if y'all let me start. I'm actually going to start if y'all listen or not. So the common denominator, what's missing here is the x plus 1 squared and the x squared plus 1, right? So on top I have x plus 1 squared times x squared plus 1, right? Correct? For the b term, x plus 1. What is missing? No. I just need a common denominator. It really is a common denominator, believe it or not. What is missing is from the original, this denominator right here. What is missing for A? A has x minus 1. It doesn't have x plus 1 squared. It doesn't have x squared plus 1. For B, what's missing? It doesn't have x minus 1, and it doesn't have another x plus 1, and it doesn't have the x squared plus 1. Do y'all see where I'm going now? Maybe? Okay, if you gave me a chance. So, x plus 1, it's missing an x plus 1. It's missing an x minus 1. And it's missing an x squared plus 1. Agreed? All right, and then there's c over x squared plus 1, no, x plus 1 squared, sorry. It is missing an x minus 1, and it's missing an x squared plus 1 from the original denominator. Compared to the original denominator, what's missing? Plus dx plus e, all of that, times, I am missing both the linear and the repeating linear. So they all have the same denominator as the original. Now I have a common denominator. Which means that the numerator of the original is equal to a times x plus 1 squared times x squared plus 1 plus b times x plus 1 times x minus 1 times x squared plus 1 plus c times x minus 1 times x squared plus 1 plus dx plus, no, yes, plus e times x minus 1 times x plus 1 squared. And guess what you do now?
Solve it. Oh.
You have to choose wisely to produce a system of equations and solve for the coefficients a, b, c, and d. And you hope and pray that they do not do this to you and make you do all of them at once. Did I put every single one of them in one problem? Yes. When I test you, I'm not going to put every single one of them in the problem. I don't want to be here all day. I can't even get through talking about a common denominator without y'all just losing it. So, how about, okay, do we agree that it's for polynomials? This is specifically when, so when is this going to happen? For one thing, what you need to know is we're doing polynomials, and the order of the numerator is less than the order of the denominator, or you're going to go do long division. First step, if the denominator is less than the numerator, is do long division. Then you might have to do this. Got it? Let's see a more realistic example. I just did everything to show you could see this is a little of everything, and that's what's going to happen. Let's dial it back a little bit and do an easy run, shall we? But I've shown you everything. This is what's coming. This is what's in college. Let's hope it doesn't happen on the AP test.
Is this Calc 3?
No, this is Calc 2. No, that's Calc 2. Calc 2, maybe. I don't know what they do in Calc.
But isn't this like algebra? Or is it like more very, very, very complicated?
That's algebra. Y'all should have learned it in Algebra 2, but we don't teach you anything in Algebra 2. No, shh. So, first example. Let's see how this works for an easier problem. Integral of 1 over x squared minus 6x plus 8 dx. Row. You can't do long division. Well, you could, but what's the point? There is no point. Yeah, they're no good options. It's not u sub. When all else fails, and my numerator is 1, that's a perfectly valid function. My denominator is the function x squared minus 6x plus 8. Can you factor it? So we're going to integrate, and we're going to factor this, and is that x, I'm looking for x where the product is 8 and the sum, because it's, notice plus, so these are going to both be minuses, right? So what multiplies to give me 8 but sums to 6? About 4 and 2. Now do you see that we can do partial fractions with it? Yes, we can. We're going to say that 1 over, and I'm going to go do my algebra off to the side, not with the calculus. Bless you. He's allergic to partial fractions. That's just amazing. So I'm going to have a over the first factor plus b over the second factor. Notice they are both linear. I don't have to worry about the repeating. I don't have to worry about irreducible quadratics. It's just two linear factors. Do you see that? So are we going to do that whole common denominator thing? What is missing here? That's my common denominator. This is the common denominator you're trying to go, that's your goal. What's missing on A? X minus 2. X minus 2. What's missing on B? X minus 4. X minus 4. So if I just look at, now that all the denominators are the same, yes? Just look at 1 equals to, the numerator, is going to be a times x minus 2 plus b times x minus 4. Do not distribute. I suppose you could, but why would you? I'm about to show you the easy way to do these. Don't make this a mess. It doesn't need to be messy. Richard. You're gonna, if I don't love you, if I stop picking on you, it means I don't love you anymore, okay? Okay, here we go. So, what you're going to do is you're going to choose wisely. We are going to choose to make a go away. How can I make the a term go away? How about if I pick x of 2? X of 2. If that's true, then a term goes away, and I just end up with 1 is equal to b times 2 minus 4, which is negative 2. So b is equal to negative 1/2. Well, that easy. Huh? We're not done yet. Oh, no, no, no. I don't want to make this hard. You're going to make it hard. I'm going to make this easy. Pick 4, because I don't want to solve for something that's a hot mess. Can I make a term go away and it'll be so much easier than plugging back in b? Do you see what I'm getting at? You can do it other ways, but oh my goodness, why would you? So for b, I'm going to get rid of b by x is 4. Does that mean this becomes 1 equals to a times 4 minus 2, which is 2, so a equals 1/2. Wow, that was easy. So what does my integral become? The integral of 1 over x squared minus 6x plus 8 dx is equal to, these are coefficients. Watch what I do with them. I'm going to pull them out in front. A times the integral of 1 over x minus 4 dx minus b, because it's a negative half, right? Integral of 1 over x, and it was minus 2 dx. Did I just take this and bust it up? Wasn't that cool? Are those easy to integrate? If you don't know your natural logs, you are so going to know them by the time we finish with this unit. So what does it equal? 1/2 natural log absolute value x minus 4 minus 1/2 natural log absolute value of x minus 2. We're going to simplify that because it's a difference, right? That means they're dividing and they have the same power. I got 1/2 natural log absolute value of x minus 4 over x minus 2. Put the half up there and now I have natural log square root x minus 4 over x minus 2. And I am done. Oh, I forgot. Plus c. I got so carried away that I could do this. I forgot to do the plus c. So I got a plus c and a plus c. And that happens to you too, and I'll forgive you.
Will you count up and we don't simplify it?
Yes, I will. More importantly, if it's multiple choice, you're not going to get the answer unless you simplify it. Why am I pushing this? Because on the multiple choice, on the AP test, it will be like that. It will not be that spread out thing. They will simplify it because there are a bunch of math professors who write this. But wait! There's more. I'm going to give you a checklist now on how to handle these. Don't you like checklists? Yeah, so that you know that there's a pattern to all this. And I'm going to give you my thoughts on the pattern. But it would help if y'all were paying attention and not talking. Okay, here's your checklist for partial fractions. 1, if it's an improper fraction. That means the order of the numerator is greater than the order of the denominator. Guess what you're going to do first? Long division. Are you still going to end up having to do possibly partial fractions after you do your long division? Possibly. But as we've seen, some of them it'll come out to something you can go ahead and integrate. But you might have to still do this. Okay, after that happens, if you still got something left you got to mess with, then you're going to factor the denominator completely. And I do mean completely. You want to get it down to linear, repeating linear, and irreducible quadratic factors. Once you've done that, then we're going to address linear factors. So your linear factors are going to be of the form some coefficient px plus q raised to the m power, meaning they could be the repeating ones, right? M could be 1, and it's just a linear factor. M could be squared. M could be to the 5th if I'm feeling wicked, right? If it's M, you must include the sum of the M factors. What does that mean? It means you have to have the first coefficient over px plus q plus the second factor over px plus q squared plus the third factor, coefficient over px plus q cubed plus ... all the way to the mth coefficient over px plus q to the mth power. For repeating ones, you have to have as many terms as there is the power. If it's a 1, so if the power is 1, which is just a linear, then you only have to have one term. If it's the raised to the power of 5, you would have to have 5 fractions, right? 5 terms. And then the last thing is quadratic. Now, I'm going to tell you about, this is like future. I don't really want to do these with y'all. They're fun without anybody watching or having to teach them. So quadratic factors can also be repeating. OMG, right? They can. And these are actually they're ax squared plus bx plus c to the n power. Oh my goodness. When you get it down to some irreducible quadratic, then they are b1x plus c1 over the a squared x squared plus bx plus c to the 1 power plus b the second x plus c the second over ax squared plus bx plus c squared plus dot dot dot, because I don't want to write anymore, plus b to the n x plus the nth c over ax squared plus bx plus c to the n power. Yuck. It's not fun, but it is possible. That's your checklist. You hope that it's not more than just one irreducible quadratic, because then, and we will do one, sometimes you can choose wisely. The linear ones are good for that, but there are other times where you're going to have to get a system of equations. This is very algebra intensive. It's going to take practice. So you should practice